Hello everyone, and thank you for joining us today. My name is Fatima Jalma, and I'm the Assistant Coordinator for the International Parkinson's Disease Genomics Consortium Africa, and I'll be moderating this session. Today, we are very fortunate to have Professor Hassan El-Fawal joining us from the American University in Cairo. Without further delay, I'll introduce Professor Hassan El-Fawal, and it's quite hard for me to actually summarize Professor Hassan El-Fawal's biography with all his achievements, but I'll do my best. Professor Hassan El-Fawal is Dean of the School of Sciences and Engineering at the American University in Cairo. He earned his bachelor's in Entomology and Pesticide Chemistry in Alexandria University. It was there that he fell in love with neuroscience and toxicology. Returning to the USA, he started a journey of discovery in Cornell University, after which he worked in generic pharmaceuticals and organic solvents industries for 3 years. He went on to earn his master's from the University of Guelph, Canada, and PhD in Biomedical and Veterinary Medical Sciences from Virginia Tech. At the American University in Cairo, Professor El-Fawal founded and directs the Institute of Global Health and Human Ecology. Professor El-Fawal's research focus has been on the interplay between the environment and genomics in precipitating neurodegenerative diseases. In particular, he is interested in early diagnostics and prognostics. However, his mission is to break down walls that impede meaningful progress and solutions for the human condition. I would like to pass it on to Professor Hassan El-Fawal. It's an honor for you to join us today, and I look forward to hearing your talk.
Thank you so much, Fatima. Well, good afternoon, everyone. Let me start by saying what a pleasure it is for me to join you, and to thank Dr. May for the kind invitation, and Fatima, who's put up quite a bit with me. Now, I'd like to accomplish a few things tonight. One of them is I'm actually going to tell you about my own journey into neurotoxicology and neurodegenerative diseases. Not so much to illustrate my background, but to illustrate the type of flexibility that we need to actually adopt in Africa as well as the Middle East. And part of that flexibility is, since we quite often in our academic institution get niched in a particular area, or our institutions are set up in such a way where straight out of high school, you begin to specialize, that we often lose the connectivity and the flexibility that should really allow people, academicians, students, to explore and discover, as well as to have a dialogue with other disciplines. So Fatima spoke about this in some of my biography, so I won't take too long. So I was actually born in Egypt, okay, and so I'm going to take you on my journey. I'm going to tell you about some of the challenges that have come my way in over 50 years of academics, how these challenges were met, and then the challenges that are confronted because I returned to Egypt after an absence, continuous absence of 37 years to become the Dean of the School of Science and Engineering. But there are challenges that have been confronted in the region, including Africa. And so there are things that we really need to address, and how we can actually meet these challenges, and what contributions I hope I've actually made in that regard. So I was born in Egypt. So I want to tell you about my journey and the destination, which is currently at the American University in Cairo. But before I even started school, I ended up in California. My father was first a PhD student there and later became a professor. On his passing, we returned to Alexandria, Egypt. This is beautiful Alexandria. Doesn't quite look like that anymore. And I entered, despite coming from a family that's very heavily in medicine, I decided I actually wanted to go into agriculture. And in particular, I specialized in entomology and pesticide chemistry. It really wasn't until my graduating year that I took our first course in toxicology. And if you know anything about pesticides, most pesticides are actually insecticides in particular, are neurotoxic. And I fell in love with the nervous system, but I also fell in love with toxicology. Well, a good way to get into toxicology is actually pharmacology. And so I spent a few years at Cornell University, actually 2 years, during which I also learned how to be a cook. So I worked as a cook on and off for about 5 years and retooled myself. And that's part of the flexibility. So somebody starts in agriculture, ends up in pharmacology at Cornell University. And after that, I actually worked in several companies, including generic pharmaceutical companies and including a solvent and chemical company, where in those days, there was actually no type of protection worth speaking about. Okay. I finally bit the bullet after a couple of years of working in industry and went to the University of Guelph, where I earned my degree in both pharmacology and toxicology in the Department of Biomedical Sciences. I actually started my PhD there, but because my advisor became the dean of the Virginia Maryland Regional College of Veterinary Medicine, I ended up in Virginia Tech. And in Virginia Tech, I, in particular, not only taught their veterinary students, but I also studied both pharmacology and toxicology. In fact, the degree reads biomedical and veterinary sciences, not medicine, but sciences. My first job was at New York University Medical Center, specifically in the Institute of Environmental Medicine, which actually broadened my horizons because I got to work with epidemiologists, I got to work with engineer responsible for remediations, with biostatisticians. And it was actually an eye-opening experience to what could come about. And you can look up the Institute of Environmental Medicine at NYU, but what can come about when people actually cooperate and collaborate together. During that time, Mercy College, which was simply a four-year college, actually recruited me as a consultant. I later went on to become the associate dean, then the dean of the Division of Natural Sciences and Veterinary Technology. But there, I not only had the previous opportunity of teaching veterinary students and medical students, but I also developed programs in the health professions, namely physical therapy, occupational therapy, speech pathology, as well as acupuncture and oriental medicine, as well as environmental health and safety. So once again, it drew on several disciplines, and that's been really part of my mission in life. In that regard, I was actually recruited by Albany College of Pharmacy. That was the name at the time. And on my joining, they actually changed the name of the college after 131 years from Albany College of Pharmacy to Albany College of Pharmacy and Health Sciences, where I actually developed programs in diagnostic medicine, cytotechnology, biotechnology, and nanomedicine. In addition, I frequently was a guest faculty at the State University of New York, several of its many different branches, which once again was an eye-opening experience. And every educational opportunity I've actually taken to broaden my horizon. Okay. I am now at the American University of Cairo, where I actually am dean of a single school that brings under a single umbrella both sciences and engineering. Okay, and people actually have a hard time describing exactly what I am. Am I an agricultural engineer, which I am not? Am I a biomedical scientist, a biologist, a geologist, and whatnot? What I want to demonstrate here is the type of flexibility we need to actually adopt in order to bring about sustainable solutions in Africa in general, as well as from a global perspective. And so this is something I will touch upon in my closing remarks. So one of the challenges that I have often confronted in my career, and I confronted even as a doctorate student, is how niched and how to, for lack of a better word, we are quite often myopic in our interests. So as a graduate student and later as a junior faculty, I was amazed how people in toxicology never took advantage of the literature in neuroscience and the methodology associated with neuroscience. But we, okay, in Africa, in the Middle East, in Southeast Asia, in South America, and even inner city United States or Europe, are actually confronted with a lot of different challenges. So according to the WHO, 25% of the disease burden in the developing world is due to the environment. I stress this because for those of us who are interested in neurodegenerative diseases, we know that the vast majority of cases of dementia, Alzheimer's in particular, or Parkinson's disease, or amyotrophic lateral sclerosis, ALS, really do not have any identifiable etiology. In fact, they are referred to as being sporadic. Yes, there is the familial form that helps guide some of the research, particularly in terms of the genomic research, but needless to say, the environment is a key factor in many diseases that afflict developing and underdeveloped countries. NCDs are non-communicable disease, such as heart disease, stroke, diabetes, cancer, chronic respiratory diseases, in addition to what we said about neurodegenerative diseases, are often associated with environmental hazards such as air pollution, toxic chemicals, the built environment, which of course, I don't have to tell you, we have issues with many of these factors. 80% of all death due to NCDs occur in the developing world. People in the developing world die at a younger age. And for those under the age of 60, it tends to be the number one killer. 25% is a pretty hefty. So the point is the environment appears to play a significant role in the health status of Africa and as well as many other continents. So by way of example, and our interest in neurodegenerative diseases, recent studies indicate that air pollution plays a role in dementia. Air pollution can actually cause brain damage, and there's some evidence that nickel, as one of the heavy metals that's part of particulate matter, including particulate matter at 2.5 microns and below, may be one of these factors. The association between air pollution and cardiovascular health, as well as vascular dementia. The association between air pollutants in the elderly in particular because of the accumulation of particulate matter. Even Parkinson's disease is not actually spared, as well as the fact that air pollutants impacts the brain. This was actually one of the headlines in the journal Science, which you, of course, know is one of the key journals. It's considered, the golden ring for many. The polluted brain and how it actually affects brain health in particular. So the point I'm trying to make here is that we actually do have a lot of environmental issues, and undoubtedly the environment, and that's where the neurotoxicology comes in, plays a significant role. The other advantage that we have in neurotoxicology is that it can provide a paradigm for the developing of diagnostic tests of nervous system damage, which is one of the focuses of my talk. This is from a recent chapter in the Encyclopedia of Environmental Health, authored by me, and it just shows you some of the associations, whether in animal models or preclinical as well as clinical studies, that have tied in major environmental pollutants with diseases such as Parkinson, Alzheimer's, and dementia, and ALS, the three that we typically are referring to when we talk about neurodegenerative diseases. So what are some of the challenges? So we have the challenges of the environment and the fact that many non-communicable diseases pose a major threat. In addition, and this has not unfortunately been updated, according to the WHO, 1 in 6 individuals worldwide suffers from neurological disorders, most of which, by the way, except for traumatic brain injury or infections, are of unknown etiology, including some of the major toxicities that we associate with. Needless to say, impacting negatively on the nervous system has a debilitating impact. It has its social and economic impact. And in children and the elderly, which tend to be quite vulnerable, it becomes a major issue. Contrary to many of the publications that we actually find, there is no one biomarker that predicts whether or not a person will actually develop these diseases. There is a significant amount of headway that's been made on the genomic front, relying on the familial forms of some of these diseases. But nevertheless, the samples that we actually draw are from people who actually have overt clinical signs. So there is a need for us to develop markers for diagnosis or diagnose the state of a disease, predict the outcome, have prognostic value, evaluate the stage or the sequela, because a marker that you may actually detect in somebody with overt clinical sign does not necessarily tell you where you are in the course of the disease. And of course, monitoring the success of intervention when we get to that point of successful intervention, where we can actually halt or prevent further neurodegeneration. The nervous system, of course, poses a lot of challenges. I really shouldn't dwell upon very long with this particular audience, but one of them is accessibility. Very few patients are actually likely to give you a section of brain for you to play around with. Okay, they tend to be very protective that way. But access to the nervous system poses a challenge for clinicians, for researchers, and for toxicologists. Okay, assessing nervous system integrity has long relied on behavioral tests, psychological evaluations, in some cases, electrophysiological evaluation and imaging. Limitations of many of these is, of course, that they are very costly and they require access to qualified professions, which in a predominantly rural or suburban community is not actually always available. Even in many urban areas on the African continent, these are not readily available. Many of these tests are limited in terms of their age, the language and geography. Language in particular becomes an issue if we're talking about a significant migrant population. Geography here, I mean in terms of access, whether to a medical center or a medical facility, and that's a major issue. And I don't have to tell everyone about some of the challenges that confront rural Africa across the board and rural Middle East. The threshold of neurodegenerative changes required to detect behavioral abnormalities is typically very high. And what is often quoted in the literature is that one needs a loss of 80%, between 60 and 80% of neurons in the substantia nigra pars compacta in order to see the overt clinical signs in Parkinson's disease. Another major challenge that we are confronted with in terms of the nervous system is the diversity. There is a challenge in terms of the region of the brain we're studying and its particular vulnerability. Is the threshold for causing damage in the cerebellum similar to the frontal lobe, similar to the motor cortex, similar to the sensory cortex? What is that threshold that is required to actually be able to detect an overt clinical sign? There is the challenge of the diversity in the terms of the cells. The brain is actually, in the central nervous system in general, is very heterogeneous in terms of its cell population. Is a Purkinje neuron of the cerebellum the same as a pyramidal cell of the motor cortex? Is it equally sensitive? Are the neurons of the hippocampus equally sensitive to those of the cerebellum? What is the threshold for the sensitivity of different cells? Neurons themselves, of course, not only have their cell body, but they have the unique processes of the axon and the dendrite. What is targeted? Is it a dendritic target? Is it the cell body? In which case, of course, the neuron in total was actually degenerate. Is it the myelin? Is it simply the axon or the terminal? And how do you translate what we know about region or about cells or about subcellular structures, where it can actually be used to detect disease, monitor disease, and monitor successful intervention. So these are some of the challenges known to most of us, and there are challenges that really have to be confronted in addition to other challenges that have to do with the environment. So one of the quests that I have been working on personally, and my laboratory has been working on since 1992, because I did bother reading the literature from neuroscience, is trying to develop high throughput biomarkers that can actually detect nervous system damage in absence of overt clinical signs. The paradigm that I have adopted, based on my background, is that we know what kind of doses and what kind of exposures to toxic chemicals, whether pesticides or heavy metals, will actually produce nervous system damage, and what is the time course of that nervous system damage, whether in children or adults, or of course in preclinical models. When I mean high throughput, this is something many of you are familiar with. This is basically the lab results, whether in terms of hematology or in terms of blood chemistry. We call these high throughput. Many of these tests that we actually take for granted were once upon a time very novel. And so I always ask the question, wouldn't it be great to be able to develop a neural panel that becomes so routine, so cost effective, that it is actually incorporated with a typical laboratory test to tell the clinician that there may be early nervous system involvement. And therefore, with the development of successful intervention, we can actually intervene and prevent the debilitating effects of nervous system damage. The other factor, and it's a major challenge, is wouldn't it be great to be able to detect it in a toddler before they actually get to this stage, and so on and so forth. But the other factor that we actually have to consider, okay, if we consider neurodegenerative diseases as a chronic state, meaning it takes years, sometimes decades to actually develop, where am I going to actually look? And this is why the routine high throughput approach is actually very, very important once it is validated. What actually quite often happens in the clinic is that a patient walks in, they may have akinesia or bradykinesia, resting tremors, if we're talking about Parkinson's disease, which is appropriate in our discussion for IPDGC, okay? In which case, the clinician, of course, will tell you, this is Parkinson's, okay? Wouldn't it be great for me to say, Mr. Smith or Mr. Brown or Hassan or Khalid or whoever is likely to develop Parkinson's disease? Do we have an intervention? Can we help them? Rather than the self-diagnosis of overt clinical signs, because Mr. Smith does not come to your clinic until family members actually notice the problem. And you walk in, does he have resting tremors versus intention tremors? Do they suffer bradykinesia, and so on and so forth? So the way we have tackled it is to actually answer the first question that many people need to answer. Can we develop markers that simply answer the question, is there nervous system damage in absence of overt clinical signs, regardless of the etiological factor? In toxicology, we refer to this as a tier 1 approach, where we basically want to say, is this chemical safe or not? What we're saying here, can I simply, regardless of etiology, develop a biomarker that tells me their nervous system damage has actually occurred? Once you've answered that question, you can become more sophisticated. And this is more of a mechanistic approach. This is focusing on the heterogeneous population of the neurons. Is it a dopaminergic neuron? Is it a cholinergic neuron, a serotonergic neuron? What brain region is actually involved, and so on and so forth. So you're defining the target specificity, and this is what we refer to as a tier 2 approach. Simultaneous with this, it is very important to identify also risk factors. So if I'm working with a human population, even at a tier 1 level, yes, I'd like to know something about the family history. I'd like to know something about their genetics. I'd like to know something about their occupation. I'd like to know something about their environment, water quality, air quality, soil quality, their nutritional status, and so on and so forth. Because things like stunted growth, things like cognitive impairment, things like poverty, needless to say, and even refugee crises and geopolitical issues do impact, of course, on nervous system health. So the approach we have actually taken is, as a result of nervous system insult and killing of neurons, you actually have a loss of proteins. Many of these proteins, by the way, are the same proteins people look for in CSF. They try to look for them in serum or plasma. Unfortunately, they tend to have a very short half-life. So we've actually gone, and these are what we refer to as acute biomarkers. But the literature validates the fact that the immune system views many of these proteins as being foreign and treats them as antigens. And so it develops a signature, and that signature is in the form of antibodies, autoantibodies, because they're directed against self-proteins, that in my laboratory we refer to as neuroantibodies. And these neuroantibodies, of course, whether depending on the class, have a significantly half-life, and they actually are expressed differently in acute and chronic states of nervous system damage. There's also the potential, which my laboratory also explores, that in generating some of these antibodies and in the presence of nervous system loss and breach of the blood-brain barrier, they may actually play a role in progression of the disease. There's evidence in the literature in models or in neurodegenerative conditions, as well as in samples, autopsy samples as well. Okay, so the tier 1 approach is, what are some of the common proteins, regardless of the type of neuron, or regardless of the type of regions? And all of you, I'm sure, have heard of the neurofilament intermediate filaments. You probably know that neurofilament, the heavy chain one, also known as neurofilament 200, is found in the axon once it's stabilized. You're probably familiar with astrogliosis and astrocytic scar following neuronal damage. EFAP tends to be that protein. And of course, the major protein associated with the myelin sheath of both the central and peripheral nervous system is myelin basic protein. And you've probably encountered this in the context of multiple sclerosis. We drew up criteria, and some of these criteria actually go back to the early work that I started in the 1990s. Well, some of you may not have been bored, is that it has to be specific to the nervous system. It should be sensitive to low levels of injury, or if you're talking toxicology, exposure. It should be objective and quantitative. In other words, if I were to train a laboratory technician who does not have the background in neuroscience or neurotoxicology, they should actually be able to tell you whether this is elevated. In other words, it's not subject simply to the interpretation of the expert. It should be accessible with minimal discomfort. This, of course, is serum. Drawing blood has become routine, and compared to the invasiveness of an MRI or a spinal tap and whatnot, it tends to be accepted. It should circumvent geographical inaccessibility. It is common across the world in medical practice that if you live in a rural community or a community that does not have a large medical center, or if you're talking about a migrant worker population to be able to collect samples and send them away to a laboratory. It should provide information on the subcellular targets and the type of neuropathology. Of course, we classify neuropathologies into different categories depending on the target. And it should ideally allow you to monitor the progression of the neuropathology, the success of intervention, and hopefully have some prognostic value in terms of recovery. Over the years, and all of this work has actually been done in collaboration, which is something I'm going to stress in this talk, with both clinicians as well as engineers, as well as environmental scientists. But these are some of the population. My lab works blindly on these samples that we get from our collaborators, whether it's in industries, it's in agriculture, or whether in our preclinical studies, which of course are done in the lab. My lab's philosophy is to tend to oscillate between preclinical and clinical, preclinical and clinical. The idea of the preclinical is to actually further validate what we see in our clinical studies. One of the studies in particular that I think is very important, and this is why the word collaboration figures in the title of my talk, is one that I was involved in that was initiated by the US Environmental Protection Agency. The reason I am particularly fond of this study is that it included the State of Michigan Department of Health, the University of Michigan, Johns Hopkins, Mercy College, as well as the Environmental Protection Agency and the National Institute of Health. And this is why collaboration is very important. What is also important is the scope of the study that looked at children in Detroit, Michigan. And the scope of the study refers to the fact that external dose to both solvents and particulate matter, particularly heavy metals, was monitored. What was also important is that internal dose actually was determined in these same children. Their immune profile, as well as nucleotide polymorphism and genomic analysis, were actually also done. And the outcomes were actually followed through on whether these children had any disease outcome. The title of the study was originally Mechanistic Indicators of Childhood Asthma, but I came in later into the study, and I actually added the neurotoxicological dimension. This type of study has actually gained popularity. In fact, I have a colleague who may actually be in our audience who will tell you nowadays this approach is referred to as analysis of the exposome, because we now realize that, particularly in sporadic conditions that we're talking about, it is the environment, it is the kinetics, the toxicokinetics of chemicals, it is the presence of infection, it is the genomics, it is many, many factors, including socioeconomic, as well as the availability of healthcare and so on and so forth, that may play a significant role. I'm briefly going to share with you some data. I would like to acknowledge, first of all, my dear friend and colleague, Darius Mason, who's actually a pharmacist, but he actually became a mentee because his laboratory was next to mine. He was particularly interested in vitamin D and polymorphism in the vitamin D receptor. But we actually started talking about hemodialysis patients, which he was also interested in, and the fact that cognitive impairment was a big part of what happened to hemodialysis patients. These are three of my students. Abby Johnson earned her bachelor's degree with me, and she works in Regeneron, which you may have heard of, because they developed the monoclonal antibody against COVID-19. Okay, that the previous president of the States was actually treated with under an experimental basis. Ali, who actually works for a contract research organization, earned a double master's, one of them with me in pharmaceutical science, and she's actually responsible for some of the Michigan analysis, but simultaneously, she also earned a master's in psychology. Yasmin Sardar, who was originally from Afghanistan, after she did her undergraduate research project with me, went on and earned her doctorate of pharmacy. Okay, so for the EPA study that I referred to earlier, we actually took a look at 23 different SNPs. These are some of them. I'm not going to concentrate on all of them. The ones I'm going to focus on are for those for glutathione S-transferase, which plays a very important role in detoxification of chemicals, including heavy metals. Let me zoom in so you see some of the relationship of the different forms, okay, isozymes of glutathione S-transferase, pi, mu, and theta. Okay, these are the particular SNPs we took a look at. And this is typically the role they actually play in the immune system. They're associated with asthma, but they have also been associated with radioactive oxygen species or oxidative stress, possibly associated with Alzheimer's and Parkinson's disease, and they have been shown to be associated with increasing the severity in ALS. Because we were also interested in heavy metals in these children, okay, it actually depends, okay. Mu in particular has been shown to play a role in increased level of mercury and arsenic, and the theta has been associated with increased risk associated with arsenic accumulation as well as dermatitis. So these are the level of autoantibodies. These are the antibodies against self-proteins in these children. Okay, and I am concentrating in particular out of the 200 children we looked at, 131 that we actually did the SNPs were quote unquote African Americans. Okay, and you can see that the IgM class against the nervous system proteins is highly prevalent. The I-GHHE class, which is associated with immunological memory and acute states, was also prevalent, but not the same prevalent as IgM. IgM, if you remember your immunology, is associated with chronic disease conditions and progression. Okay, so if we take a look at the pi SNP or the different pi SNPs, we see that there's actually with the major alleles, there's actually an increased accumulation, it's associated with increased accumulation of arsenic, cadmium, iron, as well as lead. Here, once again, the major alleles are associated with accumulation of arsenic, cadmium, iron, as well as lead, and so on and so forth. When we did multi-regression analysis, we actually saw that for appearance of anti-neurofilament M, that's the medium level IgM, there was positive association with this particular SNP of pi, as well as cadmium and iron. For neurofilament H, that's the heavy one, okay, significant association with the same SNP, okay, as well as cadmium and zinc. And the bottom line is that the particular polymorphism associated with a particular glutathione form was either associated with an increased metal level or was a major determinant, and this is the p-value. You can see they were highly significant with the particular SNP or metal association. There was also a negative association and in the case of the different glutathione forms, that was actually considered to be protective. When we looked at some of the polymorphism associated with expression of cytokines like IL-4, and this is for anti-neurofilament heavy chain, you see that once again, the major allele was the one that's more likely to be associated with heavy levels of this autoantibody. Likewise, in the case of GFAP, and once again, this is all IL-4 These are the particular polymorphisms that we actually took a look at. Likewise, for TNF alpha, which everybody knows plays a significant role in neuroinflammation, as well as allergies, including allergic asthma, the major allele was more likely to be associated with antibodies against neurofilament L or antibodies against myelin basic protein of the I-GHHE class. Okay, the volume of data that was generated by this collaboration, incidentally, is still ongoing. So much of these studies, even though it's been presented at international conferences, is still work in progress for publication. Okay. Now, I said that Dr. Darius Mason, my lab neighbor and collaborator, was actually interested in vitamin D. Why was he interested in vitamin D? As it turns out, worldwide, including the Middle East, okay, and in North Africa, there appears to be actually a vitamin D epidemic. And that vitamin D epidemic is quite often associated with the fact that vitamin D is a neuroimmunomodulator, and therefore it may be implicated in neurodegenerative disease as well as autoimmune diseases. Okay, vitamin D deficiency has been associated with cognitive decline in Alzheimer's disease. And vitamin D deficiency has also been associated with Parkinson's disease. Now, one would think that if you live in Africa, including North Africa or in the Middle East, with all that sun, that we may actually not have an issue, and that is absolutely positively not true. Our lifestyles have changed where actually, despite the fact that we live in the sunshine belt, we actually have major issue. I would invite you to take a look at this article in particular, which came out in the Lancet in 2017. And the title is Vitamin D Status in Africa is Worse Than Any Other Continent. And if you take a look at this particular study, this is a systemic review that basically, wow, a significant part of the population is actually pretty bad off in terms of vitamin D status, and that this is an issue despite the fact that year-round we have sun. So Darius was interested, Dr. Mason was interested in the vitamin D receptor polymorphism, and these are the particular types of SNPs that he was actually interested in. You can see that some of them are associated with variants. Variants in FOC1, for example, have been implicated in Parkinson's disease. They may also be associated with lead accumulation, and I'll tell you why we brought in lead here. Variants here in BSMM1 may also be associated with Parkinson's disease, and variants in APA and TAC1 may actually be associated with dementia and Alzheimer's disease. Vitamin D receptors, or the VDR, is highly represented throughout the brain, including in the cingulate gyrus, the thalamus, the hippocampus, but one of the highest concentration of vitamin D receptors is associated with the substantia nigra, which of course is of interest in regarding to our presentation. These are variations depending on ethnic group. They are derived from several studies, and you can actually see that for the different polymorphisms, there are actually also ethnic or racial variations. Here we looked at the autoantibodies, and we compared our non-white population, which included African Americans as well as Hispanic and Asians, and you can actually see that there's variability in the distribution of the different alleles, okay, from major to minor. These are the level of antibodies that are found across the board in the white and non-white populations combined. And you can actually see that for these particular alleles, they were significantly higher than this particular. The minor allele here appears to be protective. If we jump to TAC1, likewise, the major allele, okay, the homozygous major allele appears to have higher level of antibodies, and the minor appears to be protective. And this is actually the distribution between major and minor in the different groups. But here it's actually associated with blood lead levels. And you can actually see that there was a significant difference between the major allele and the minor allele for BSM1, and the major difference or nearly significant difference for TAC1. The same groups that we saw here were more prone to have higher levels of autoantibodies. Why did we bring lead into it? Because in the literature, it actually, for some reason, indicated that people who go on hemodialysis and develop cognitive impairment are more likely to accumulate, even though you're getting rid of electrolytes like calcium, sodium, even potassium, they tend to accumulate heavy metals, and lead tends to be the major one. Surprisingly enough, the literature is actually silent on where that lead could actually be coming from. Is it from water supply? Who knows? Okay. This is the distribution of IgM and I-GHHE in a continuation of the same population. And you can see that IgM, which is associated with chronic disease progression, was the one that was primarily represented in our hemodialysis patients. If we stratified according to the cause of the renal failure, those with diabetes, type 2 diabetes, were likely to have higher antibody levels compared to those with glomerular nephritis. Hypertension played a significant role in some of these individuals, and PCD is polycystic disease. So the bottom line is hemodialysis patients do suffer a cognitive decline. There's indication of nervous system insult using the autoantibodies, and there may be an association with environmental exposure to lead. So, do we have any unique challenges? So I came back to Egypt in 2016. In fact, I'm going within 3 months. I will have been here 5 years. And we do. This is one of our major challenges. One of our major challenges is that we have become so stratified and focused on our own little pet project or our own niche. And it reminds me of that story of the 3 blind men, one that touches the elephant and says, this is a tree trunk, one that touches the tail and says it's a brush, and one that takes the trunk and says it's a garden hose, not realizing that what we're taking a look at is a living creature. What I am actually saying is what is actually needed is for the different expertise to learn to speak a common language that will enable them to actually work together. Okay? And so even when we look at the United Nations 2030 Strategic Sustainable Development Goals, to me, the 16 other goals all actually focus on the need for good health and well-being. But if you take a look at these individuals, they involve nutrition, they involve environment, they involve agricultural sustainability, they involve water resources, they involve food resources, they involve sanitation. All of these are health issues, which means all of these individuals with their interests should be actually speaking to each other, because a healthy human is the healthy human who could actually fulfill these sustainable goals. And so one of the other challenges that we have is the argument that has actually gone on for decades. And that argument talks about whether we are a product of nature or nurture. I want to put this in the language of what we call precision health. Some of you may use the term precision medicine. I will tell you what the difference between in my book is. But in our language, we now talk about gene-environment interaction, and that gene-environment interaction, whether it's nature or nurture, is ultimately responsible for you, including your health status and your outcome, inclusive of brain health and brain development, okay? Where we actually fall short quite often is how we define environment. Environment, particularly if you're talking about a fetus, okay, but not only the fetus, but a developing child, okay, is their nutritional status. That's also the nutritional status of the mother. It's also the value of the nutrition. It's not quantity, it's the value of the nutrients in that food. Environment also refers to the occupation. Where does that person work? All of us, I believe, have some kind of background in pharmacology or toxicology. If we're physicians in particular, an occupation we know impacts significantly on organs, metabolic organs like the liver. Okay, environment also refers, where do you live? How do you live? Do you live in the inner city? Do you live in an urban community? Okay, do you live in a ghetto? Do you live in the slum? Do you live in a rural area? So on and so forth. How do you live? What are the environmental exposures associated with how do you live? What's the water supply like? What's the air quality like? What's the soil quality like? Okay, is there a dump next to you? Is there a landfill? And so on. A lot of African countries, unfortunately, are taking e-waste from China, and that e-waste is very rich in mercury as well as other toxic heavy metals. Okay, they're doing it. There is no precautions on how it is actually processed in many of our countries. Okay. Education level plays a significant role, and there are numerous studies that show an education level impacts cognitive function as well as the likelihood of developing dementia, whether it's Alzheimer-like or not. Okay, socioeconomic status. Okay, socioeconomic status. Do you have availability of healthcare? Do you have a clinic in your neighborhood? What's your sanitation system like? Do you have access to a physician? Okay, or are you living hand to mouth? Okay, we of course now know that there's a keen interest in the microbiome and its role in the possible development of neurodegenerative condition, whether we talk about the gut-brain axis or the oral cavity brain axis, and so we know it plays a significant role there as well. Okay, even if it's not genetic, it may be epigenetic, whether we're talking about methylation or acetylation, okay, other factors that can switch on genes, some of them protective, some of them harmful, or shut down genes. Our geopolitical crisis, nobody, absolutely nobody in the audience, I'm sure, will tell you that refugee crises and wars and migrants and malnutrition and environmental refugees is not likely to have a neurological impact on whole generations. And it doesn't matter whether we're talking Middle East, Asia, Africa, and so on and so forth, okay? Key point, ethics, okay? Quite often when medical research or health-related research is done, the patient is quite often, unfortunately, treated as a guinea pig. This is a very big, big concern, okay? And of course, even though many countries, okay, across the world, including in Africa and Asia, have policies and regulations, enforcement is totally absent, okay? How did I meet this challenge? When I joined the School of Science and Engineering, actually on the plane, my way to interview in May 2016, one of the things I noticed is that within, and this is the advantage of having both under the same umbrella, is that there was clusters of interest in these different areas: biomedical, environment, public health, built environment, sustainability, energy resources, renewable energy, information technology. And the problem was, and it's a problem that we confront throughout the Middle East and Africa, they weren't talking to each other. Even the people within biomedical interest or environmental interest or health interest were not talking to each other. Okay? That idea of bringing them together is actually what created the human ecology part of the Institute of Global Health. Okay? When you took different interests of faculty within these different clusters, you noted that there was actually an interest in global health issues. And there was actually two major centers that were involved in this. One was called the Research Institute for Sustainable Environment. The other one was the Center for Sustainable Development. They have been brought together to form what's called the Center for Applied Research on the Environment and Sustainability, or CARES. And it is their contribution, plus bringing in a very successful counseling psychology program in the social sciences, as well as bringing policy and communication and economics together, that created, along with partners, what we now refer to as the Institute of Global Health and Human Ecology. What makes this unique, okay, across the board, definitely within the Middle East and in most of Africa, is this is an institute that does not just cater to physicians. It actually draws on the expertise that is required to create public health. And that's why we don't use the term precision medicine. We use the term precision health because we recognize its genes, its environment, its lifestyle, its socioeconomic status, its belief systems, and its practices that are actually required to be brought together, regardless of whether you're in the omic niche, a diagnostic niche, an environmental niche, a targeted therapy, or social and behavioral status. I always believe in walking the walk and not simply talking the talk. So despite the fact that I'm not actually required to teach, as dean, I put together a course for seniors and grad students that brings people across the board from the university, from engineering, from science, from psychology, from economics, into what we call crosstalk, where we attempt to tackle real world problems, where teams that are required from being from different disciplines need to speak to each other. Okay. So what other challenges do we have in MINA? Well, we have the 7 deadly sins. Across the board, it doesn't matter where I look, whether I'm talking about Egypt, North Africa, Sub-Saharan Africa, the Middle East, across the board, everybody's so protective, mine, and we have silos. And I will give you examples. I had a physician contact me one day, a neurologist, and he says, Dr. El-Fawal, I hear about the kind of biomarkers you do. I have some samples for you. And I asked him, great. So you're going to send me serum? He says, no, I'm sending you whole blood. And I said, wonderful. Okay. I told him, I take it you just collected them recently. He says, no, they've been sitting in the fridge for the last 2 months. And I told him, please take them and throw them out because I cannot use them. He said, why? I told him, well, you're a physician. Don't you know how to separate serum? Or don't you have a clinical pathology department? He says, we don't talk to those people. We collect our own samples. Silos, people who have common interests but do not speak to each other. We need to break down those silos if we really want to have sustainable solutions. The training of health professionals and the training of biomedical scientists and the training of engineers needs to be such, okay, where they can at least articulate a common theme, communicate. We're not saying everybody has to be an expert in all things. We're saying they need to be able to know who do they need to work out with. I work with physicians, I work with veterinarians, I work with environmental engineers, I work with water engineers, I work with sanitation engineers, I work with physicists, I work with chemists, and the list goes on. but we need to have a language of communication. And therefore, we need to actually have a dialogue. If everybody's sitting in his own corner, okay, that becomes an issue. And so resources actually become very important. Quite often people have very expensive resources. They tend to be very protective of these resources and they don't share. Okay, we need to learn how to play nice and share. And sharing here doesn't mean within a single institution. Sharing can actually be across the continent. Because if we take responsibility for our continent, for our populations, for our citizenry, and so here we're talking social responsibility, we collaborate. We can actually produce sustainable solutions. And we need empathy, okay? We need empathy towards our patient population. We need empathy towards those less fortunate. We need to work with them not because I know better than they do, but because they're actually partners towards finding sustainable solution. And ethics becomes a very important issue in this regard. I am actually, and I'm going to be blunt, rather appalled at the number of places across the continent, including Egypt, where people poke and prod patients, collect samples from patients without proper consent. Okay, and I can actually give you examples, okay, that I have personally encountered. Okay, and that is very important. It needs be part and parcel of our training. It goes to the credibility of the data we generate. It goes to the credibility of the data we share. It goes to the credibility of finding proper therapeutic interventions. And so it's not a matter of simply producing a publication. Quite often, and when it comes to publication, we are in such a rush to publish that we actually publish in no-name journals. And therefore, even though the quality of the work may be very good, its impact is totally negligible because nobody knows it exists. And once again, I can give you examples of cases I've encountered, whether when I was in the States or since I've actually returned to Egypt. So the big question, why it's important to have this dialogue. Every single person or profession that you see here works in the health sector, whether it's physicians, nurses, dentists, veterinarians, chemists, biologists, physicists, artists, data scientists, social workers, economists. And in fact, in a 2014 study commissioned by the Center for Disease Control in defining what the public health workforce taxonomy, who it includes, indeed, all of these professions are represented, okay? This is how you bring about sustainable solutions by speaking to each other. And of course, it involves you, okay? So I was told that I should actually end my talk with a quote or a bang. I have two quotes for you, okay? If we're interested in the precision health and precision medicine, I've always found this to be an appropriate quote. It's actually from Hippocrates, okay, who lived across the street from us, across the Mediterranean. And it says it's far more important to know what person the disease has. In other words, who is at risk. If you know who's at risk, and this is why IPDGC and the genomic work and IPDGC Africa in particular is very important. What is the profile? Genomic, environmental, social, economic, that puts a particular person at risk rather than simply what disease the person has. Okay, this is not my quote. This is my quote. My quote is, if we are content to imitate, then we are content to be behind. Because quite often we find a very interesting article that comes from the States or comes from Europe, and we simply imitate it. And when we don't get the same exact results for risk genes, for example, or risk polymorphism, we think we've actually failed. Okay, if Dr. Salama, my colleague who actually works at the American University, was with me, he would actually tell you that he looked for LARC and PARC and everything else typical risk gene for Parkinson in Egyptians and didn't find it. He discovered something else, the K variant for butyryl cholinesterase. Okay, but if we are simply going to imitate all the wonderful studies that come from elsewhere, rather than innovating, we're always going to be walking behind. And this is a pharaonic thing, appropriate, and you have all these soldiers all walking right behind each other. But if we have the will to discover and to innovate and to take our future and our expertise, because we have expertise, I'm willing to bet that at least 60% of the audience was trained in the US or in Europe or elsewhere where they are actually recognized experts. We have the expertise, we have the talent. And if you do that, then you actually lead. Okay. So on that happy note, I would like to thank you for your patience. I think I went a little bit over time. And whereas the brain has two hemispheres, I hope as a result of these wonderful webinars that we can actually work as if we are a single hemisphere. Okay? Doesn't mean we don't have a corpus callosum, guys. Okay, that's not what I'm saying. Okay? But at least like the corpus callosum, speak to each other, work together, and work towards sustainable solutions. And I turn it over to you, Fatima.
Thank you very much, Professor Al-Fawal. It was incredibly informative and inspiring to hear your journey and your thoughts, and you've given us many things to reflect upon. If anyone has any questions, feel free to leave them in the chat box. I think we've gone a bit over time, but I do have one question. We've talked a lot about collaboration.
Yes.
I would like to also ask you, for any students or early career researchers who are in the audience, what key advice would you give them for starting off in their own journeys?
First thing is, I would basically say, don't ever be shy, okay, and bashful about reaching out to people. It's like what I tell my students. I tell my students, there is no stupid question except the question you never asked, okay? So basically, it's not going to cost you anything if you find a colleague you want to collaborate with to send them an email. You may have to send it 2 or 3 times. Okay, you've experienced that with me, Fatima. You've had to remind me 200 times to get you a title. Okay, but eventually I did answer. Don't hesitate to pick up the phone. Don't hesitate to say, I'm interested in working with you. Be very clear on what the outcome is. Your collaborator is your partner. Your collaborator is not simply a source for samples, okay? So everyone I've worked with in doing my analyses blindly, that's a collaborator, okay? They know they are actually part of the project. They're not simply giving me a sample and by nice knowing you. But you have to take that first step. You have to reach out. The fact that there is an IPDGC Africa is an example of reaching out, finding common grounds and finding common interests. And that's the very first step. And it doesn't matter. Geography is no longer an issue, by the way. Yes, there are regulations if you're sending samples or whatever, okay? But geography is not really the issue anymore. It's the willingness to work. And it's also, more importantly, not just to work together, but learn from each other. Okay, so I will not claim that I know everything, okay, and I don't know everything. Otherwise, I would not have gotten involved in all these disciplines if I already knew everything. And that's why you also, if you educate yourself, and this is something I stress on my graduate students, very first step is you have to educate yourself, okay, because you also want to come off as sounding like an intelligent life form who knows what they're talking about. You're not going to ask somebody to collaborate if you just sound like you just woke up and you haven't given some thought to what you want to do with them or how you want to engage them. That's very important. So educate yourself. Don't be bashful about reaching out. Okay, it doesn't cost you anything in today's way of communication. There's no more stamps that you have to go to the post office and stick.
Yeah.
It's
Yeah.
just a bunch of electrons that you're going to send across the net.
Yeah, that's so true. Thank you.
Yep.
I think you might have a question. Okay, so we have a question from Martina William. Will you please recommend sources to understand more about precision medicine and to find research gaps in this field?
Sure.
Yeah.
You can actually share my email, by the way, with people, and I can actually send them some resources.
Okay.
Okay.
Yeah. Sure.
Okay. Most of what I spoke about, by the way, in this particular talk, particularly pertaining to my work, if you just simply Google my name, you'll actually, PubMed, you'll actually run across a lot of this work. Or Muhammad Salama, who I believe has already spoken in this particular forum. There's a lot of information there, and it actually has also our contact information. Okay. So I invite anybody who's interested in anything I said or opportunities to work together, and I believe my name is also on the IPDG's group.
Yes, yes. Okay, thank you. Thank you so much, Professor Hassan El-Fawal, for joining us today and for giving such an inspiring talk. I'm sure we've all enjoyed it. This session has been recorded, so it will be uploaded, and I will send across, as Professor Hassan has agreed,
okay, there's
well,
something
the
in
email address.
There's something in the chat. Will you please recommend certain okay. Yep. All right.
Yep. So thank you. So yeah, I think people are expressing their gratitude.
Yep.
Yeah. Yep. So thank you very much, everyone, for joining us. And again, thank you again, Professor Hassan El-Fawal, for giving this talk.
My pleasure. My pleasure.
Okay.
Take care.
Take care, everyone.